Pretty. Can't wait till it fails epically. And it's a total bust. Just no production over 35 volts or so. Also, my HVIC is fried again. These relays obviously do not hold up, so it's a project wasted. With the exception, I may try to scrap the control system and modify these standard relays to be more high voltage friendly somehow. Interesting configuration I have here. We have a primary bifilar wound coil right here, which is a little bit heftier than my normal primary coils are as far as gauge and number of winds. Let's say in comparison it's about the same size as this inductor here. Really not that big. This is a much more meatier primary, many more winds, heavier gauge. What to be exact, I couldn't tell you. Looks like maybe 4 wraps, maybe 16 individual coils per wrap, so you do the math. What's on top here is just a dual bifilar opposite wound inductor. I'm going to say that again. A dual bifilar, so we have 2 bifilar coils on this bobbin, opposite wound. So this one is wound one direction, the other one is wound the opposite direction. Dual bifilar wound opposite direction coils. This one is configured as a bifilar secondary center tap, no ground. It's just a center floating tap right there. The other ends of it go to the other bifilar winds, the other 2, which are the 2 inductors respectively. And just first try here, I'm nailing nice equal opposite polarity pulses. Look at that. Even during the pulse off time and on time, that's pretty interesting. Pushing 38 volts across my 26X cells. Consuming a bit of amperage there. 900 hertz, 58% duty pulse. So previously getting pulses during the on time, and it looked like there's off time as well, but I ended up reversing the polarity on my primary. Now look what I'm getting. Equal opposite polarity on the pulse off time. And we got 40 volts at the cell. 200 milliamps. We're pulsing at 1.3 kilohertz. 42% duty cycle. But the real thing is, like, we're only pulling 1.4 amps at 28.8 volts. Beautiful equal opposite polarity pulse. Residual voltage in the cell. Pulse again. Allowing us 42% duty cycle. I'm talking 40 volts there. Extrapolate that out across what I would normally have here is 6 cells. 6 by 6 cells. So it would be 2, 4, 6, 8, 10, 12. We'd have 120 volts there. Now I'm pretty confident at this point that the voltage capability of my setup here is just the cells themselves. I do need a bigger gap, which means a smaller diameter inside, smaller ID, which would be essentially thinner tubes, thinner outer tubes. The thinner the outer tubes, the more distance there is in between these 2 tubes. More gap, more resistance, more voltage available. Additionally, my new cells are going to be 7-inch, not 4. So that should increase capacitance, and I'm guessing there will be a decrease in capacitance because of the larger gap between them, but hopefully the extension of the cells would provide more capacitance to maybe equal that out. Further testing must be done. But I mean, like, this is a pretty basic setup here as far as, 2 bobbins. And I mean, this primary coil here is doing just awesome. I'm going to try switching out to a more standard one that I use here, wherever I did with that here a minute ago. This guy, and see what the amperage is that way. Look at that though, isn't that beautiful? We have maximum voltage potential. Maximum force being exerted between the plates when it is equal opposite polarity. This accounts for the lowest amperage at the cell and the lowest amperage input. We have a balanced setup. It's very difficult for electrons to travel when we have a balanced setup. Which for me, balancing is just having 2 coils do the exact same, or more or less, and then just one wound in opposite direction. Alright, other primary in there. And you may ask yourself, why was that vertically last time? Well, this thing was just a little bit too tall vertically, obviously, and I had to really compress that down to get the ferrite cores to stick together. There may have been a slight gap, I don't know. Okay, so this gets a little wilder. Plug your ears. We are now at 36, 37 volts, almost the same voltage. But look at our amperage at the cell. It's 0.082 instead of 200. So it's only 82 milliamps, but we're down to 20 volts, 1.6 amps. So that's less wattage than previously, if I can do math in my head right. I need to have a calculator here so I can just do this without stopping my video. Look how basic this thing is. This is basic. Like, we're getting voltage. I don't know, not much here. Primary coil, bifilar wound. You know, I'm probably giving the specs on that before from my previous videos from my other transformers. And this here, again, this is, I believe, single wrap. There's no additional wraps. It's just one wrap straight through, bifilar, and then the other way straight through, opposite direction wind, 2 dual wound bifilar coils, one a centered tap floating ground, and the other ones that are wound opposite direction are essentially the inductors, A and B. I can't tell you exactly how this is wired up here. I'm going to try to determine that here in a minute. I really doubt there's enough from this video for you to really determine what goes where. All these are bound together through these little alligator clip cables. There's a diode connected there. And you just have to recreate it yourself if you want to. I did the math, 32 watts of power to create almost 40 volts, which would be 120 volts at the cell if it's expanded across, which also means our amperage typically goes down as our voltage goes up, as we add more cells, as our previous videos. So, I mean, if we're previously making 1/10 of a milliliter per minute, and we were down to, let's say, 32 watts of power to make that, bro, I feel like I might be unalive soon.
This is Stand Revenge.
Let's watch it again, shall we? Anything over 20, we start kind of maxing out, not really getting anything anymore. We're 37.9 volts. I can kick that down to 20 volts and have pretty much the same voltage at the cell. Not even 100 milliamps. There are bubbles being made. We're at 1.82 kilohertz, 50% duty cycle. Adjusting the frequency, we got to 38.4 volts, and we're down to what? 10 watts? 82 milliamps at the cell. We got 38 volts, and we got this waveform. What are my cells doing right now? They're producing a decent amount. But look at my input consumption. This is ridiculously low. Ridiculously low. 4.4 kilohertz, 50% duty cycle. Let's see if we can adjust this, get this even higher. I'm increasing the... Nope. let's try to decrease the pulse width. No, okay, so there's a sweet spot right here. 75, 76, that's right, 51. Yep. About 50-50. Switch to polarity on the primary. So we get the same waveform. Maybe we can increase duty pulse now and get higher voltage. Ooh, saucy. Hold on here, brother. Brother, do you see what I am seeing? Holy shit balls. Oh my fucking lord. Okay, we're still only at like, you know. Ooh, this is juicy here, guys. Wow. Holy crap. Yeah, cells are producing accordingly. Hold up a second here, dog. I'm gonna pause this. Okay, so this gets crazier and crazier, dog. Alright, hold up. So here we go. This is 45 volts. Let's see if we get up to 45 volts here. And we're doubling that, so 60 watts. Bro, that's still ridiculous, but we're getting the voltage at the cell that we want. If we get 45 volts at the cell, hold up. Understand what that means? Understand what that means? Hold up. 60 watts. My voltage cap, the glass ceiling has been broken. Guys, this is huge. And I don't know if I'm gonna post this video now, quite honestly. Damn it. Dude, if I'm originally getting 150 volts, 160 maybe on my best day with my toroid, and I was pulling tons of amps, you know, what, 6 amps at 30 volts to make that happen. Here, we've achieved it with 60 watts of input power. Look at that, 46, 45 volts, 260 million. These cells are producing bro. I can't believe this right now. Here all along, I thought this was so much more complicated than what it needs to be, but in reality, like, here we have it. This is such a simplistic setup. It is beautifully simplistic. Man, those things are puking appropriately for that voltage. It's taken me a few moments to kind of collect myself of where I'm at. I want to bring a couple documents to you guys' attention here. WFC memo 420. WFC electrical polarization process requires natural water only, which is what I'm doing. Voltage dependent exponential gas yield. Amp restricting. You can see linear amp flow. What is this? Mode of operability. Voltage dissociation of the water molecule. Chemical interaction, current dependent, requires electrolyte. So basically traditional DC electrolysis. Gas yield is on a linear scale, whereas with voltage potential restricting amps, much higher gas yield. Per this one here, number of pulses per second. Help restrict amp flow. That's the applied voltage. We have a point here that we read where gas production is increased up until resonant action, and then once we reach that, we can then get a gas yield of many, many more times as we increase frequency and applied voltage from there on out. But real quick sidebar, this here, a center tapped bifilar wound coil. Let's see here, secondary is bifilar, essentially with a center tap ground, producing both positive and negative pulses at the same time. This is a different configuration where we have the load connected to that ground, which some people theorize with stand stuff like that's actually how he's set up, which is possible. But from my experience, we leave that floating and connect this down here. Diodes could be switched or reversed, or just that one diode right there. I don't believe you need that second diode there, but that is, in essence, delivers the equal opposite polarity pulses to the load, being your cells, rather than just polarity pulses. Garble on this one later. It's opposite wind also delivers that. Back to my case in point here, though. And look at this here for the, I don't know what non-linear means, but cylindrical resonant cavity. Look at that, guys. Dynamic electrical stress of opposite polarity. That's what that is, man. Here's the actual linear cylindrical resonant cavity. Look at that. Static electrical stress of opposite polarity. Wow, difference for potential. Ever expanding pulsating electrical stress across water gap? I'm getting way distracted here. Let's get back to the point at hand. My God, I can't find the image I'm looking for, and it's going to drive me bonkers. Let's kick this baby back on. Judging by this setup here, this being more or less a standard inductor that I've wound, should be single wind. However, that could be a triple wound. I'll have to disassemble that to find out. We'll maybe measure some values here when we have a moment. Bifilar clockwise, bifilar counterclockwise. Primary coil, which I've described in other videos. 20 winds bifilar. Looks like in just two directions, going bap and bap, back and forth. Could be 4 layers, but I don't think so. I'm guessing probably 60 to 80 winds per coil. Bifilar, it's hard to judge. But again, just the first bifilar wind in a center tap, floating ground type of configuration, with the outputs of that going to the other two bifilar winds respectively for the inductors. We got it up to 32 volts. We are 45 volts at the cell, 300 milliamps. Those cells are producing. Our needle here is just beginning to bump. There's our bubbles, but pretty stellar amp consumption. And here I thought this whole time I had to wire or wind giant secondaries to get voltage where I wanted to be, like ridiculous coils to get crazy voltage, when literally all we needed were just these two tiny little coils. These two dual wound bifilar opposite direction coils. That really makes me wonder, where do we go from here? Winding these coils differently as far as two, basically a quad file, all in the same direction. What then? Different configurations as far as, back to the matrix switchboard. The matrix switchboard is not hooked up right now. It is an utter failure. The relays and whatnot just don't want to work the way I need them to. So we're going to do a manual type of configuration henceforth. Not ideal, but I'm stuck with it. So anyway, so it's just, connected through these alligator clips right now. I'll try to document exactly what connection goes where so we can be on the same page here. I want you to, whatever you're doing, download the plans for this device. Just these two simple coils you can wind. 3 technically. And I've already showed you how to make these cells. You just got to get some stainless steel, like I specify. Make some enclosures. Like these things. Connect the Chinese PWM to it. And linear power supplies. Oh, I haven't even messed with my snubber yet. Holy crap. I wonder what this is going to do. Hold up. Alright, let's check this snubber real quick. 500 ohm. It's getting me this. at 45 volts. Production. Less than 2 amps. Less than 200 milliamps of the cell, and 44.5 volts right there at that moment. Bro, I think I'm crashing mentally. Not really, just it's late, and I just pretty much did calculations. That was bullshit, and I just want to make sure I'm gonna be true to my peoples. Fuck's sake. Okay, I'm out. It's late.
This is Stand Revenge.